Hello everyone, welcome to your favorite YouTube channel BYJU'S Exam Prep. I am Deepak Mishra and here we are discussing ISC PYQ series and we are starting operating system. Already I have finished DBMS and most of the subject like C and COA has been finished. In this class, we are going to discuss about operating system PYQ that is based on process management and deadlock. So my dear friend, be with me. For 40 minutes, we'll try to solve each and every problem. We'll try to analyze the question also, like which type of question they has been asking 2002, 8 and 2016, my dear friend. So, moving forward, this is my profile and yeah. So, please join this Telegram channel if you are not joined yet for daily dose to improve concepts, and you can get the notes, and if you have doubt regarding the class or if you have doubt in any subject, you can ask me in this Telegram channel so I can clear your doubt. Even though and like various experts are there for a specific subject, they can take your doubt. So UPSC ESE 2023 mains exam has been released. You can share your result and you can get free mock test with our expert panel. So now we start process management, and this is the very first question. Very easy question. Fine. See clearly. I'm reading here, which of the following scheduling algorithm is non-primitive? They are asking non-primitive, my dear friend. So everyone know we have two type of scheduling algorithms, primitive and non-primitive. Fine. So which of the following scheduling algorithm is non-primitive? They have given the option round robin, multi-level queue scheduling, first in first out, and multi-level queue scheduling with feedback. Fine. Multi-level queue scheduling with feedback, my dear friend. Can you please tell the answer? I'm waiting for 1 minute. Can you please try to give the answer? Anyone? See clearly. Okay, I'm solving now. See, it is non-primitive. They are talking about non-primitive. Non-primitive, my dear friend. So see, round robin, it's primitive algorithm. If time quantum expire, the process will what? The process will what? Preempt, and another process will be scheduled to the CPU. Everyone know. So it is primitive scheduling algorithm. Round robin is primitive. It is based on time quantum. Fine. First in, first out. See, first in, first out it is non-primitive scheduling algorithm. Everyone know it is nothing but this one is non-primitive scheduling algorithm. Fine. What is the meaning of non-primitive? Suppose if I have a process, if I am running this class, until and unless if I will not finish this class, I will not leave this room. Are you getting my point? Fine. Non-primitive means until and unless if I will not finish my execution time, I will not leave the CPU at all. Whatever happen outside, I don't care. Until and unless if I will not leave, I will not complete my execution time, I will not leave the CPU. So first in, first out is nothing but it is what? Non-primitive scheduling algorithm. It is non-primitive scheduling algorithm. Fine. Talk about this one. Multi-level queue scheduling. See, multi-level queue scheduling is non-primitive. No, it is also what? Primitive scheduling algorithm. You know, like multi-level queue, we have multiple queue. We have multiple queue, my dear friend. And see, we have a higher level queue. We have high priority queue and we have a lower priority queue. Fine. Once the higher priority queue process has been scheduled or has been executed, then lower priority process will be executed. Fine. So it may happen, see, preemption will occur. It may happen, let's suppose like higher priority process queue will be finished, then medium priority process will be finished, then lower priority, let's suppose it still go for it won't go for the execution. Now the higher priority process will come. What will happen, my dear friend? The lower process which are in lower queue will be preempt, and the process which having higher priority will be scheduled and ready for the execution. So you know, multi-level queue scheduling is also what? Primitive. And multi-level queue scheduling algorithm, it is based on round robin. Everyone know. Fine. Round robin. We have like multiple queue with gradually decreasing, you can say, or decreasing time quantum. So it is also what? It is also based on what? Primitive scheduling, because it is based on what? Round robin. Fine. So the answer is what? First in, first out. But see here, they will not ask definitely this question in next year or upcoming year. Maybe they will make it MSQ. What they will do, they will make it MSQ. Or what they will do, they will try to test your knowledge. Maybe they will ask, which of the following algorithm is suffering from starvation? Maybe this is the next question. Let me ask you. Can anyone say starvation? I'm talking about starvation, my dear friend. Starvation. Anyone say? Can you please let me know which of the following scheduling algorithm is suffering from starvation? Starvation, my dear friend. So you should have very fair idea about that. Fine. Maybe that is 1 number question in next GATE exam. See clearly. So round robin. I think everyone in round robin there is no starvation because there is a time quantum. Fine. Process will schedule to the CPU. So no starvation. No starvation. No starvation. Okay, I'm writing here. No starvation. No starvation, my dear friend. Okay. First in, first out. First in, first out, my dear friend. No starvation. No starvation. First in, first out also no starvation. Oh, sorry. No starvation. Fine. What about multi-level queue scheduling algorithm? In multi-level queue scheduling algorithm, there is a starvation. Fine. So here it is starvation. Starvation. Why there is a starvation, my dear friend? I think everyone know. In multi-level queue, what we have? We have what? Multiple queue. Fine. So like we have a higher priority queue, we have a medium priority queue, we have a lower priority queue. Fine. Once the higher priority process will be finished the execution, then only lower priority process will be finished the execution. You know. So what will happen? Let's suppose we have three different queue, my dear friend. See, this is higher priority queue, this is lower priority queue, this is higher priority, and this is nothing but lower priority queue. See, and see, after completion of this queue only, this queue will be executed. After completion of this queue will be executed. Let's suppose, see here, we have like higher priority P1, P2. Then we have, let's suppose P3, P4. Let's suppose we have P5, P6, my dear friend, P5, P6. Let's suppose P1, P2 completed. Then P3, P4 will be executed. Then P5, P6. Let's suppose P5, P6 we want to go for execution. But see here, one more higher priority process will become. See here, let's suppose P8, P9 will become. P10, P11 will become. P10, P11 will become. P11, P12, P13 will become. So what will happen if this strategy will follow? If higher priority process keep on coming, what does mean? This process will wait for indefinite amount of time. That is nothing but starvation. So this process got starved. Starvation means waiting for indefinite waiting. So this process will get starved. So in multi-level queue, there is a starvation. Maybe they will ask, that's why I'm discussing, my dear friend. Sir, what topic? Definitely you will you'll get the information soon, my dear friend. Probably maybe DBMS or some other subject, but definitely you will get. Okay, so come to this one. So multi-level queue, we have a starvation. See, from question, we are making question here. Fine. Multi-level queue scheduling with feedback. So some people have doubt here. So in multi-level queue scheduling with feedback, there is no starvation. So in multi-level feedback queue scheduling with feedback, in multi-level queue scheduling with feedback, or you can say multi-level feedback queue scheduling, there is a starvation, my dear friend. Here also we have a starvation. Here we have also a starvation, my dear friend. Here also we have a starvation. Fine. Because I told you, say in multi-level feedback queue, what we have different queue with gradually different queue with gradually like decreasing time quantum size or increasing time quantum size, what you can say. Fine, increasing time quantum size. So what will happen if let's suppose if lower time quantum keep on coming, lower time quantum process keep on coming, what will happen? The process which are in the last level queue will not get executed. Are you getting my point? What I'm trying to say? In multi-level queue, what we have different queue. We have different queue like this. Let me draw here. We have different queue with gradually increasing time quantum. If I told decreasing time quantum, see here. Please correct it. So time. Let's suppose time quantum 2. Let's suppose time quantum 4. Let's suppose time quantum 6. Are you getting my point? Time quantum 6, my dear friend. See here. And there is a C. This will add to here. This will add here. And if it is finished, the output will be add here. See, let's suppose the process will come and time quantum is 2. If time quantum, let's say burst time is 2. To time quantum expires, process has been finished, no problem. Fine, time quantum 2 expires. If it is left, it will move to the next queue. It will left, it will move to the next queue. Are you getting my point? And finally, we have FCFS. Some textbook they have written FCFS also, no problem. What I'm trying to say here, just listen clearly, my dear friend. See, see here, if a smaller time quantum process keep on coming, what will happen? The process which having what largest time quantum will not able to execute. So it will stuck. So here also we have a starvation. Once again, I'm repeating. If a smaller time quantum process keep on coming, what will happen, my dear friend? See here, this process which having largest time quantum will not able to execute. So my dear friend, there is a starvation. So what we do basically, some people have also doubts that we have a aging technique. Sir, aging technique. We have aging technique for like so that we can remove starvation. Yes. So multi-level feedback queue with aging technique, you can remove starvation with aging technique. What is aging technique? The process which are waiting for longer time, we can increase the priority of that particular process. Or you can say the process have more age, you can increase the priority of it. Or the process have the more waiting time, you can increase the priority of it. So my dear friend, so multi-level feedback queue scheduling, here you can apply aging. If aging is there, no starvation. If there is no aging, my dear friend, starvation is there. So if aging is there, there is no starvation. Fine, there is no starvation. Aging, you cannot apply multi-level queue scheduling algorithm. You cannot apply aging here. You can apply aging here, my dear friend. So see, just I have given this logic for you. Like maybe that particular question has been asked in GATE. Fine, maybe that particular question has been asked in GATE, my dear friend. So be ready. What I'm trying to say, see, round robin, first in, first out. See, no starvation. Multi-level queue scheduling algorithm, starvation. Multi-level feedback queue scheduling algorithm, starvation. Multi-level feedback queue scheduling algorithm with aging, no starvation. Fine, no starvation. Even though, see here, if you see all like SJF, SRJF, fine, priority, primitive, non-primitive, all have starvation, all have starvation. Longest job first, starvation. Longest remaining job first, no starvation. Fine. Are you getting my point? So you can note this point. If you want, you can note this point. Okay. Okay. Now see this question. See question number 2. A process execute the following code for I equal to 0, I less than n, I plus plus fork. The total number of child process created is. The total number of child process created is, my dear friend. The total number of child process. The total number of child processes created is. Fine. See here. So we have option n, we have option 2 to the power n minus 1. We have C option 2 to the power n and D option 2 to the power n plus 1 minus 1. See clearly. See clearly, my dear friend. See, fork everyone, it is a system call. Fine, it is a Unix system call. With the help of that, we are able to create the child process. Fork is nothing but it is a system call. In Unix, it is a system call to create child processes. Fine. So we have n processes they are telling. How many? This is n. This is nothing but n. So we have n fork system call. So if we have n fork system call, how many number of child process has been created? So it is easy question, see clearly. Let me write one example. Let's suppose main. And let's suppose we have fork. Just I want to explain. And let's suppose I am printing print OS. Do not bother about the syntax and all. See. So just I want to, okay, someone telling D option, okay. See here. So I just want to tell, how it will create the child process, because I already told what is fork. It is a system call in Unix operating system in order to create child process. Okay. See here. So what will happen? So this is nothing but this is your code. Fine. This is your code. So see here. So fork, what it will do, my dear friend, what you would have to do, it will create one child process. And see here, this fork system call, it will create one child process. Fine. And you can write the same thing as it is without fork. Main, and we have what? Printf OS. We have what? Printf OS. So this is nothing but child process. Fine, this is nothing but child process. Are you getting my point? See here, what happen if we have one more fork system call? Let's suppose In this main, we have one more system, one more fork. So let me write here if you want. See main, just I want to tell you how it will come. Main, and let's suppose what we have fork, and we have one more fork, and let's suppose we have printf hello or printf OS, whatever. See clearly? So for this one, what will happen, my dear friend? Due to this fork, one child process will be created, and it will contain what? It will contain main, fork, and printf OS. So main, what we have, my dear friend? We have fork, and we have what? Printf OS. This is one child one, fine. Now, my dear friend, due to this fork, this one more child will be created. Just I am linking this one because it is same only. This is C2, you can say. And due to this fork, one more child process will be created, my dear friend. It is nothing but main, and what we have, printf OS. See here. So how many child? C1, it is C2. For this one, it is C2 and C3. See here. So how many forks? How many fork system call? Two fork system call here. So how many child process is there? 1, 2, 3. See, if one fork system call, we have one child process. See, one fork system call, we have one child process. If we have two fork system called, we have three child process. Are you getting my point? If we have two fork system call, we have three child processes. Are you getting this? So which formula is verifying? Can you please let me know? See here. So see here, it is n. It is equal to n? No. See here, one system call, one child process. For this one, you can say yes. But for this one, see here. Here we have two fork system call. We have three child process. So n is not the answer. N is not the answer. Are you getting my point? N is not the answer. Now see here. 2 to the power n minus 1. If you put 1 here, see, if you put 1 here, because we have one fork system call. So it is nothing but 2 to the power 1 minus 1. It is nothing but 1. Fine. So see here, we have one child process. If you put 2 here, let's suppose we have two fork system call. So if you put 2 here, 2 to the power 2 minus 1. This is nothing but 4 minus 1, 3. Yes, it is satisfying. So it is nothing but, what is the answer? Answer is what? B for Bombay. B for Bombay, my dear friend. B for Bombay. Is that clear? So this is the formula also you can note down. If we have n fork system call, fine. If we have total, if we have here n fork system call, the number of child process will be 2 to the power n minus 1. Okay. Total number of process, if you can say, see, total number of process will be changed. Total number of child process will be 2 to the power n minus 1. Okay. I think you got this. You got the point. Total number of n iteration will be there, na? N process will be there. Fine. Okay, try this one. Try this one, my dear friend. Try this one, please. Please try to give the answer for this one. Which of the following statement about synchronous and asynchronous is not true? Please try to give the answer. Anyone? Okay, so I'm solving this. Which of the following statement about synchronous and asynchronous IO is not true? IO is not true. See here, an ISR is invoked on completion of IO in synchronous IO, but not in asynchronous IO. See, for this one, you need to know about synchronous IO and asynchronous IO. See here, So what we are studying in operating system, it is what synchronous IO. Fine. I think you know the state. Like here we have ready, and my dear friend, we have running. And we have what? Waiting state or IO state or block state, whatever you can say, waiting. I'm not bothering about new and termination state here. Fine. See clearly this one. So see, what we are studying in operating system, it is all about. See, we are not bothering about suspended block, suspended ready and all. Fine. See, we are discussing this problem. Even though see we have new state, we have ready state, we have suspended ready state, we have termination state, we have suspended waiting state, but there is no need of this one. I just want to focus on synchronous and asynchronous. Fine. Asynchronous IO. Fine. So what is the meaning of see here synchronous IO, my dear friend? See clearly what is the meaning of synchronous IO. Just I want to tell what we are studying in OS. That is what synchronous IO means. See here. Let's suppose see here any process is running in ready state. It will what? It will be dispatched to the running state. Fine. Whenever it require any IO, it will go to the waiting state. Are you getting my point? It will go to the waiting state. I think this point is clear. See, in ready state we have multiple number of processes here now. Fine. So one of the process will bring from the ready state. Fine. Will bring from the ready state and dispatch to the running state. If it required IO state, it will go to the waiting state. If IO is complete, it will go to the if IO is complete, it will go to the ready state. If IO complete. So this is nothing but synchronous IO. Fine. So in synchronous IO, what will happen? See, if any process need IO operation, it will go to the blocked state or waiting state. Fine. If IO is complete, it will go to the ready state. Fine. So here what we have, my dear friend, see what they have written here. An ISR is invoked on completion of IO in synchronous IO, but not in asynchronous IO. Fine. Not in asynchronous IO. See here. So what we have here, we have interrupt service routine. Fine. Interrupt service routine. In COA, you have, I think you have already read about this statement, interrupt service routine. It is nothing but an event it is an event handler. Fine. If a program is in ready state, either it is in ready state or running state or waiting state, it is in main memory, my dear friend. It is in main memory. Fine. Program either is in ready state or running state or waiting state, it is in main memory. It occupied main memory only. If it is a suspended ready state, it means it is in secondary memory, or suspended waiting state, it is in secondary memory. I think you are getting my point. Okay. So here, where we are. So see here, with the help of interrupt service routine, the process P0 will be what bring from the waiting state or blocked state and schedule to the ready state. So the work of, you can say, event handler. What is the working of this event handler? वो क्या करते हैं? The process will bring this process, fine, and schedule in the ready state. Are you getting my point? So we have an event handler here. But my dear friend, in asynchronous IO, it is not happening. In asynchronous IO, it is not happening. In synchronous IO, like what we are studying, that is same only. But in asynchronous IO, my dear friend, if any process required IO operation, it will not go into the waiting state. It will continue its execution. My dear friend. So how it can continue its execution? So my dear friend, any program is like, you can say it is a like collection of like lines of one lakh lines of code, and every code does not require IO. That's why, my dear friend, in asynchronous IO, whenever IO is required, it will not go to the waiting state. It will continue its execution. With the help of handler function. Fine. In handler function, all specific thing is there. Fine. All details are there. So it will continue the execution. It will not go to the waiting state and then ready state. Are you getting it? It will continue execution. And after the completion of execution, my dear friend, the function will inform, okay, it is completed. Are you getting my point? Please reply. So see here, an ISR is invoked on completion of IO, is synchronous IO, but not in asynchronous IO. So I think first option, if you see, I think it is correct one. A is correct one. If you see B, in both synchronous and asynchronous IO, an ISR service routine is invoked after completion of the IO. No. So here we don't have ISR. In asynchronous IO, we don't have ISR, my dear friend. Fine, we don't have ISR. In asynchronous IO, we don't have ISR. See, now a process making a synchronous IO called waits until IO is completed, but a process making an asynchronous IO called does not wait for completion of the IO. A process making a synchronous call wait until IO is completed, but a process making an asynchronous IO call does not wait for completion of the IO. And in the case of synchronous IO, the process waiting for the completion IO is woken up by the ISR that is invoked after the completion of the IO. No, this is also wrong. This is also wrong. I think you got my point, what I am trying to say. Fine. If you have doubt, you can ask me, my dear friend. If anyone have doubt. See, once again, I'm telling if you have doubt. See, in synchronous IO, we have ISR. In asynchronous IO, we don't have any ISR. We have a signal mechanism. Whenever the process is complete, it will signal. Fine, it will signal the process. Fine, the process has been completed. Okay, they are asking about not true. They are asking about not true, my dear friend. So, okay, fine. I think we did wrong here. Okay, fine. So, option will be because not true. So, let me tell you. Not true will be not true because they are asking. Okay. Because I think meanwhile one student has asked the question. See, so an ISR is invoked on the completion of IO. In synchronous IO, but not in asynchronous IO. This is true. This is true. In both synchronous and asynchronous IO, ISR routine is invoked after the completion of the IO. No, this is false. This is false. I think B is the answer. Fine, B is the answer. If you see the third one, a process making a synchronous IO call waits until IO is complete, but a process making an asynchronous IO does not wait for completion of the IO. Yes, does not wait for the completion of the IO. I told you very clearly. Fine. In the case of synchronous IO, the process waiting for the completion of the IO is woken up the ISR that is invoked after the completion of the IO. Yes, this is also right. This is also right. In the case of synchronous IO, the process waiting for the completion of the IO is woken by the ISR. Here we have a ISR that is invoked after the completion of the IO. Yes, that is true. So I think this is true. This is true. This is also true. Sorry for the mistake. Fine. So B is the correct. B is the not correct answer. Not true means false. So B is false. I think this is clear. B is false. Sorry for that glitch. So B is the answer. B is false. Fine. Okay. Now see clearly. This is question number 4. Consider the following processes with the arrival time and length of the CPU burst given in the millisecond. The scheduling algorithm used in primitive shortest remaining time first. They are using primitive SJF, or you can say SRJF. SRJF, shortest remaining time job first. And they are asking about turnaround time, the average turnaround time of this process H. Fine. So they are using SRJF. Okay, solving. Okay, you can please solve. Last question is clear because they are asking about not true. Done. Okay, I'm solving now. See clearly here. So SRJF, you need to draw the Gantt chart. So please try to solve. Draw the Gantt chart first. Okay, I'm solving now. I think, see, it is the easy one. See here. So see here we have 4 process. Arrival time is there and burst time is there. Draw the Gantt chart. It is very easy. It is SRJF means primitive SJF. See here, process starting from 0. So 0. See here, at 0 we have only one process and burst time is 10. So we have only one process. So you can keep this process directly, P1. We have only one process here now. We have only one process. See here. So it is nothing but, see, you can put P1 here. So see, the next process will come to 3 and the burst time is nothing but 6. So see here, no need to check after 1 minute. See, after 1 minute, no need to check, wasting of time only. So you can take only time interval, arrival time only. So you can run 0 to 3. So see here, it become what, 7 and it become what, 6. Because we are using primitive SRJF, so the process which having lower burst time will be scheduled to the CPU first. So this process will get preempted, P1 will get preempted and P2 will be allocated. Fine. Now see here, what is the burst time of P2? 6. See here, now we need to check at 7. So at 7 the burst time is 1. Definitely it is lower than this one. 1 is lower than the remaining time of burst time of P2. So P2 will run till what? P2 will run till 7. So it will run how much? It will run how much? 4 seconds. So it is nothing but 2. It is nothing but 2. 2 will be left. So my dear friend, 3 to 7. Now I am at 7. We have only one. We have P2 and P3. So because P3 having lower burst time, that's why P2 has been preempted and P3 will be scheduled to the CPU. Now P3 having only one burst time, so 7 to 8. So now I am at 8, my dear friend. Now I have got all the processes. See here, the remaining burst time. See here, it is 0 and it is 3, it is 2, it is 7. So the process which having lower burst time will be scheduled to the CPU. So P2 will be scheduled to the CPU. So 8 to 10. 8 to 10. Now we have, see here, we have P4. So it becomes 0. Now we have what, P4, my dear friend. So P4 will be scheduled 10 to how much? P4 is nothing but 10 to 13. And after that 13, what we have? P1. So we have P1. It is nothing but 20. Right? It is nothing but 20. Is that clear? Very easy question. Very easy. Gantt chart is clear. Now they are asking about turnaround time, average turnaround time. So you need to find the completion time. Write completion time here. What is the completion time of P1? P1 completion time is nothing but 20. See here. P1 completion time is nothing but 20. Fine. What is the completion time of P2? P2 completion time is nothing but 10. P2 is 10. What is the completion time of P3? 8. 8. What is the completion time of P4? 13. 13. Fine. Is that clear? Now if we see clearly, turnaround time. So turnaround time is nothing but completion time minus arrival time. So you can just do subtraction. 7 minus 0 is 7. 20 minus, it is nothing but, completion time. Turnaround time. Turnaround time is completion time minus arrival time. So 20 minus 0 is 20. This is nothing but 20. Fine. Now we have what? 10 minus 3 is nothing but 7. 10 minus 3 is nothing but 7. 8 minus 7 is nothing but 1. And 13 minus 8 is nothing but 5. Fine. This is nothing but turnaround time. They are asking about average turnaround time. So you can just add it. 20 plus 7 plus 1 plus 5 divided by how much? 4. So it is nothing but 27, 28, 33 by 4. 33 by 4 is nothing but 4 8 ja 32 and 1, 4 2 ja 8 and 4 5 ja 20. 8.25 is the right answer. 8.25. So you fill in the blank question. 8.25 is the right answer. If you have any doubt, you can ask me. 8.25 is the right answer. If you have any doubt, you can ask me. If you have any doubt, you can ask me. Okay. This is very easy question. Fine. See, SRJF, arrival time they have given, burst time they have given. Fine. So at time 0, we have only one process. So that particular process will be scheduled to the CPU, P1. Now, no need to check after 1 millisecond. See here. We need to check after every 3. See, 3, 7, then 8. So at 3, my dear friend, it is the remaining burst time of P0 is 7. And the burst time of P2 is 6. That's why the P1 has been preempted and P2 will be scheduled to the CPU. Are you getting my point? P2 will be scheduled to the CPU. Fine. So P2 will be scheduled. After that, see here at 7, P2 is remaining 2 and P3 is 1. So that's why P2 will get preempted and P1 will be scheduled, P3 will be scheduled to the CPU. Fine. Now see here, now we reach all the arrival time. The process which having lower burst time will be scheduled to the CPU first. It is very easy question. Okay. Okay. See last question, see clearly. For last question, B answer because not true they have asking. Not true. Why not true? If you have doubt in this question, you can ask me. Not true. Because meanwhile I have taken some other question, so that's why I have not written carefully. So not true. Sometime it may happen with you also. So be careful. Not true. So see the option. This is true, this is true, this is true, this is false. ISR, see, if someone asks you difference between synchronous and asynchronous, my dear friend. So in synchronous IO, if IO will occur, it will perform the IO operation. Fine. It will go to the waiting state, and then after the completion of IO, it will go to the ready state. Fine. And who will do this? Interrupt service routine will do this. Fine. But in asynchronous IO, if any IO will be occur, it will not go to the waiting state. It will continue the execution with using the handler function. And after the completion, it will what? Send the signals. It will send the signals. Sir, why it is happening, sir? Sir, why IO? If IO is occur, it will not preempt and continue the execution, because see here in a program we have well-like lines of code. Every instruction does not require IO. Some instruction does not depend on the IO. That's why. So in asynchronous IO, it is not depend on the ISR. Fine. It is depend on handler. Like in asynchronous IO, we have a handler function. We have a signals. Fine. So in option, if you see clearly, C and D is right. A is also right. What I told, that thing they have written. Fine. Okay. So I'm moving now. I think you understood this point. Okay. Now this question, this is also very easy question. So consider an arbitrary set of CPU bound processes. CPU bound processes means those processes who are spending more time in CPU. There are two types of processes, CPU bound processes and IO bound processes. The process which are spending more time in CPU is called CPU bound processes, and the process which are spending more time in IO called IO bound processes. With unequal CPU burst length submitted at the same time to a computer system. Means like at the same time all process has been arrived and the process having different burst time. Which of the following process scheduling algorithms would minimize the average waiting time in the ready queue? So my dear friend, whenever this kind of question comes, directly you can answer shortest remaining time first. It will give you minimum average waiting time and turnaround time. Fine, you can directly take. If you want, you can take any question. Fine, you try to solve it. It will give the minimum average waiting time. Fine, so shortest remaining time first is the right answer for this one. Because see here it is unequal, they are telling, and they are also telling all are arriving at the same time. All are arriving at the same time. Means there is no starvation also if all processes arrive at the same time. Fine. Okay. So now talk about synchronization, that is very important. So before this question, you need to solve this one. Before this one, you need to solve this one. This is easy one. Then we'll come to the previous one. So they are talking about consider a non-negative counting semaphore S. So there are two type of semaphore. I think everyone know binary semaphore and counting semaphore. So binary semaphore have value 0 and 1, and counting semaphore have value minus infinitive to plus infinitive. Fine. The operation P of S, decrement S. Fine. Everyone know P of S is nothing but down of S. It will decrement the value of semaphore. And V of S means it is nothing but signal of S. It will increment the value of S. During an execution, 20 down operation and 12 up operation are issued in some order. The largest initial value of S for which at least one PS operation will be remain blocked. They're asking about the largest value of S which at least one PS operation will remain blocked. One PS operation. So what will be the value of counting semaphore if it is blocked? One process will be blocked, -1. I think everyone know. Fine. Counting semaphore value actually tells, like, if it is negative, how many processes are blocked. If it is positive, you can say positive means how many processes can perform successful, you can say down operation, successful down operation. Are you getting my point? Successful down operation. And if it is negative, you can say how many processes are blocked or how many processes in the suspended list. See clearly. So let's suppose semaphore value is S. We have 20 P operation means -20. And we have 12 V operation plus 12. It should be equal to what? Because they are telling at least one. See, they are telling at least one PS operation will be remain blocked. It is nothing but -1. Find the value of S here. So it is nothing but S. This is -8. So it will go -1 plus 8. So it is nothing but S equal to 7. So for S equal to 7, at least one process will remain blocked. Very easy question. See here. I have taken S as a semaphore value. This is 20 down operation. This is 12 P operation. And they are telling we have at least one process which are getting blocked. That's why it is -1. Fine. Now come to this question. Now come to this question, my dear friend. See here. In this question, what they are telling, the P and V operations on counting semaphore, where S is an counting semaphore, are defined as follows. Fine. So they are clearly have mentioned it is a counting semaphore. It is a counting semaphore. And I think you know, they have also mentioned here, see, they have also mentioned here down operation and up operation. See, it is nothing but P of S. P of S is nothing but down on S. S की value को S से एक decrement कर दो. If S less than 0, then wait. This is nothing but your down operation. Fine. P of S means S value will become S -1. If S less than 0, then wait. Then V of S. Now see here, it is nothing but V of S means S plus 1. And if S is less than equal to 0, then wake up a process waiting on S. If S is less than equal to 0, then wake up a process waiting on S. So it is nothing but they are explaining, they are defining what counting semaphore, up and down operation. I think you know this one already. This is nothing but down operation. This is nothing but up operation. This is nothing but up operation. Up operation. Now they're telling, assume that PB and VB, the wait and signal operation on binary semaphores are provided. Now they're telling, assume that PB and VB are wait and signal operation on binary semaphore, right, are provided. Two binary semaphore XB and YB are used to implement the semaphore operation PS and VS as follows. In the next PPT it is there. So see clearly here. So they are telling P of S is nothing but PB XB. S value is S -1. If S less than 0, then VB XB, PB YB. Else VB XB, VS PB XB and S equal to S plus 1. If S less than 0, VB YB and VB XB. Okay. The value of XB and YB they are asking. The value of XB and YB they are asking, my dear friend. The value of XB and YB they are asking. See clearly. So they have given XB and YB value. XB and YB value. And they have clearly mentioned here, two binary semaphore. XB and YB are binary semaphore. Means XB and YB value can be 1 or 0 only. It is binary semaphore. It is not counting semaphore. It is binary semaphore. So the value of XB and YB is what? 0 or 1. So in option also they have given 0 or 1. Say clearly 0 or 1 only. That's why they have given 0 or 1. So my dear friend, XB and YB 0 and 0, they have given 0 and 1. So see the first line. If you see the first line, it is down operation on XB. See the first line here, it is down operation on XB. So if you take 0, my dear friend, down operation will never be successful. it will be unsuccessful because XB is what? 0. Down on XB will be -1. It will got suspended. Here also it will got suspended. Fine, because both are down operation. Both are down operation, so it will got suspended, my dear friend. So this cannot be the option. So 0, starting with 0, it cannot be the answer. So A and B you can easily remove. You can easily remove. Why? Because see here, both are down operation. If XB value is 0, so down on 0 will be unsuccessful. Down on 0 will be unsuccessful. Are you getting my point? Now we have C and D. Now we have two options. Either the answer will be C or the answer will be D. Let's see what will be the answer. See clearly. So let me take some value here. Let me take semaphore value is 2. S value is 2. Let me take S value is 2. Fine, semaphore value is 2. Because it is a counting semaphore, you can take 2, 3, 4, whatever. Fine, it's up to you. S is a counting semaphore. See clearly, and I am taking here, let's suppose we have P1, P2, P3, fine, P4, we have some 4 processes are there. 4 processes are there. So S equal to 2 means, what is the meaning? 2 successful down operation means 2 process will be inside the critical section at any point of time. 2 process will be inside the CS. Fine, 2 successful down operation. So let me try to analyze this code here. And see here XB value is what? Let me take this code. Let me take D first. Let me analyze D first. So let me take XB value is what? 1. And here YB value is also 1. XB value is also 1 and YB value is what? Also 1. Are you getting my point? XB value is also 1 and YB value is also 1. So see clearly what is happening down on XB. So down on XB, 1 becomes 0 successful. First line I am writing. First line. This is first, let's suppose first. So down on XB, successful, unsuccessful? Please tell me, successful. So because down on XB, see here, down on 1 becomes 0. So 1 becomes 0. Now see here, down on 1. So I'm writing here, down or whatever P on XB. XB is what? 1. So it is successful, no problem. Now S equal to S minus 1, second line. S equal to S minus 1. No problem. What is S value? 2. So 2 equal to 2 minus 1. You know, S equal to what? 2 minus 1. It is nothing but 1. So 1. So S value is nothing but 1. If S less than 0, is S less than 0? No. S not less than 0. So we need to what? See. Else what? VB XB. So just increase the value of F. Here it is what? It is 1. 1 become 0. Now 0 become what? 1. Now 0 become 1. Are you getting my point? 0 become 1. Fine, 0 become 1. Now let's suppose, see here. Let's suppose, or you can say, let's suppose it is inside the critical section. Let's suppose it is here only. It is here only, my dear friend. It is here only. Let's suppose P1 will come. What will happening? P1 will come. See, let's suppose it is not, it's become what? 0 become 1. Due to VB XB, it is 0 become 1. Are you getting my point? Let's suppose P1 wants to come. If P1 wants to come down on XB, so 1, see it is successful. 1 becomes 0. Now S equal to S minus 1. What is S value now? S value is what? 1. S value is what? 1, my dear friend. So 1 minus 1, 0. 1 minus 1, what? 0. Are you getting my point? 0. So 0. 0 less than 0. 0 is less than 0. Can you please tell me? No. So it will come this part. VB XB. VB XB. Once again, XB become 1. So 1 to 0 and 0 to 1. Now see here, P1 is already in critical section. P2 is already in CS. Now P3 wants to come. According to the counting semaphore, because I have taken S equal to 2, maximum 2 process will be inside the CS. Fine. But see here, if 3 will come, what will happen? If P3 will come. So down on XB, 1 becomes 0. Successful. What is S value? S value is what? S value is what, my dear friend? It is already 0. It is already 0. When P2 come, it is already 0. See here, 0, see, S equal to 0 minus 1. It is nothing but minus 1. See, if S less than 0, is there S less than 0, my dear friend? Yes, S less than 0, my dear friend. If S less than 0, see, VB XB. VB XB means this XB become once again what? 1. And PB YB. So, down. What is the value of 1? Successful down operation, my dear friend. Successful down. It becomes what? It becomes what? 0. So, it comes into the critical section. So, what does mean? See here, this is not the correct. This is not the correct. Why? Because if S equal to 2, maximum 2 process should be inside the critical section. Are you getting my point? But here, P1, P2 and P3 also. Why? Due to this one. Due to PBYB. Due to PBYB. If it is become 0, let's suppose if you put 0 here, what is happening? What is happening, my dear friend? It is unsuccessful down operation. So, P3 will not execute further. P3 will be stopped here. So, that's why the answer will be what? 1 and 0. That's why the answer will be what? 1 and 0. 1 and 0 will be the 1 and 0 will be the right answer. Are you getting this? 1 and 0 will be the right answer. 1 and 0 will be the right answer. Okay. Is that clear? 1 and 0 will be the right answer. See, for this question, you can easily remove A and B for looking this first operation, because it is down, it is down. If it is 0, if XB is 0, my dear friend, the execution will not move forward because it is down, unsuccessful down operation. Fine. But if you take 1 and 1, what is happening here? For S equal to 2, I am taking. For S equal to 2, I am taking, my dear friend. So for S equal to 2, we are seeing here, maximum 2 process will be inside, but here 3 process due to this one, PB, YB. But if this YB will become value 0, it will got suspended. I think this one is clear. Okay. Now see this question, my dear friend. Consider the following 2 process synchronization. So if you see this question, I think you are aware about strict alternation. Fine. This is nothing but a strict alternation. If you see clearly, this is nothing but 2 process solution, strict alternation. Fine. See here, they have written, see here, while entry loop while turn equal to 1, critical section, exit turn equal to 1, loop while turn equal to 0, critical section, exit turn equal to 0. The shared variable turn is initialized to 0. Which of the following is true? They are asking which of the following is true, my dear friend. See clearly. So turn is 0. Turn is 0. It is a strict alternation, my dear friend. Turn is 0. So let's suppose, can see 0 equal to 1. Condition is what? False. Condition is what? False. If condition is false, what will happen? See, it will continue the execution. See, 0 equal to 1. See here, now P0 inside the critical section. P0 inside the critical section. Are you getting my point? P0 inside the critical section. Now check for this one. Now check for this one. See, my dear friend, P0 already in critical section. Can process P1 will come into the critical section, my dear friend? See clearly here. See, what is turn value? Turn value is 0. 0 equal to 0. Condition is true. And it is what? Semicolon. What does mean, my dear friend? If condition is true, it will keep checking the while loop until it will become false. When it will become false? When P0 will exit the critical section and it will what? Make it turn 1. It will make it turn 1. So what is happening? What is happening, my dear friend? It will satisfy mutual exclusion. It will satisfy mutual exclusion. Means only one process at a time will inside the critical section. Either process 0 or process 1. When I will make it turn 1, let's suppose process P0 will go. 0 equal to 1, condition false. P0 inside the critical section. Then after execution of critical section, it will make turn equal to 1. Now, my dear friend, now here, now the turn will become 1. So 1 equal to 0, condition is false. Now, my dear friend, P1 will come. Now, my dear friend, P1 will come. And it will make once again after executing, turn will be equal to 0. Fine. So mutual exclusion satisfied. What about progress, my dear friend? Progress not satisfied. I think you know. It is nothing but strict alternation. Fine. Strict alternation means P0, P1, then P0, then P1. It will run in what? Alternate manner. Are you getting my point? जिसका turn होगा वही process CS के अंदर आएगा. Let's say P0 in critical section. Now P0 exit. P0 comes. P0 wants to once again come into the critical section. It cannot because now the turn value is 1. Fine. So it is nothing but a strict alternation. Progress is not satisfied. I think you know what is progress. Fine. Let's suppose, see here, in this case also, let's suppose P0 आया, फिर P0 CS से बाहर निकल गया. Fine. Let's suppose फिर P1 आया, फिर P1 CS से बाहर निकल गया. Let's suppose P1 वापस से आना चाहता है. P1 wants to come again into critical section. But who is waiting? Waiting is P0. Who is waiting? P0, जो कि non-interested है. Sir, please tell us, currently studying 3-1 semester. If I want to apply for GATE 2024, but my university has now do not release result. Yeah, you can take if result नहीं आया है. See, you are in 3rd year. Definitely you are able to apply. But for this one, I think you should take some document from your university or college. Fine. Some document you need to you need to attach. You can ask your department. They will help you out. Like if you are in 3rd year, definitely you are able to apply the GATE exam. Fine. But for this one, you need some document. Fine. Some proofs. Your department will be definitely provided. Okay. So I'm moving forward. See, deadlock will this part we'll discuss tomorrow. Deadlock and memory management we'll discuss in the next class. Fine. So I think hope this all question is clear. If you have any doubt, See, this question is nothing but strict alternation. So for this one, what will be the answer? I think answer is not there. Progress is not satisfied about this one. Progress is not satisfied for this one. Fine. If you see this one, fine. This one we have already done s equal to 7. For this one, C, the answer will be what? 1 and 0. C is the right answer. For this one, shortest remaining time first we have seen. If you have any doubt, we can ask me. Okay, fine. So deadlock we can discuss tomorrow. Fine, we can discuss tomorrow deadlock and other questions. So those, see here, those who scored 30 by 13 in engineering mathematics in GATE, fine. Our favorite Rakesh Talreja sir, fine, live on 6 September 7:30 p.m. You can register now, fine, on BYJU'S exam prep app. If you want to get 13 out of 13 marks, okay, and take a step towards success in GATE. We have a national scholar test program for GATE exam. You can get 90%, maximum 90 up to 90% off. And if you want to enroll, we have a like Vision GATE 2024, a course for GATE computer science aspirants. So like for this one, we have a live classes, recorded lectures, study material, practice quizzes and mock tests. Fine. If you want, you can join as soon as possible. And this is my Telegram link. Please join this link if you have any query. See, Ravi, you can just ask to your institute. Fine. There is you need some proof. If third year result has not come yet, how you can apply for GATE? Because there is a requirement of result also, na? Like some attested copy they will give you, like you are in third year and with grades such and such. Fine, they will give some on their letterhead they will write something like that. Fine, that will help you out. Okay, so yeah, so those who have not subscribed the channel, please subscribe the channel and please like it and share it. Thank you so much. We'll meet you tomorrow, not tomorrow, on Sunday, and we'll try to solve rest of the question. Thank you so much.